So, hi everyone, welcome to Physicscoach. Look at this question. First of all, read the question carefully. A light wave is propagating with plane wavefront of the type x plus y plus z is equal to constant. The angle made by the direction of wave propagation with the x-axis. So, equation of wavefront is x plus y plus z is equal to constant. Let us suppose this constant is c. Okay. In xy plane, in xy plane, what is zero? Z is zero. Then what we will get? X plus y plus z is equal to c. Now if I draw x plus y plus c, it is just like this: x upon 1 plus y upon 1 is equal to c. So if you draw like this, x plus y is equal to c, the x-axis, this is y-axis, and this is z-axis. Now x plus y is equal to c, it will be like this. Clear? Then this coordinate will be c comma 0, and this is 0 comma c. Clear? In xy plane. I'm not showing like the Z. Okay, Z will be 0. If you want to write like Z also, its coordinate will be 0, comma C, comma 0. Okay, C 0 0. Clear? If you want to write Z also, no worry. You can also write comma 0. Clear? Similarly, comma like this. Similarly, if you in YZ plane, what 0? X. X is 0. If X is 0, then Y plus Z is equal to C. Then how will you draw y plus z is equal to constant? It will be like this. Y plus z. Okay? And this coordinate will be what? On z axis, x and y is 0. Then it will be x 0, y 0. Clear? But z is not 0. On y axis, what is 0? X is 0, z is 0. X is 0, z is 0. Means y coordinate will be 0, comma c, comma z, 0. This coordinate again I will write. This is 0, comma c, comma 0. Similarly, the equation will be, what is the equation of this line? Y plus z is equal to c. Equation of this line is x plus y is equal to c. Similarly, this equation will be in xz plane, it will be like this. Now you are getting some plane. Okay. In x, y, z, this is our wavefront. Which I have drawn. Here, in xz plane, what is 0? Y. So it will be x plus z is equal to c. Now you got one important figure. This is the plane, is a wavefront. This is the wavefront, which is mentioned in the question: x plus y plus z is equal to constant. So equation of this plane wavefront, is x plus y plus z is equal to constant. Now we know the concept. The direction of wavefront is given by the direction of light, direction of ray. There, a ray is always perpendicular to the direction of wavefront. For example, our wavefront is like this. Plane wavefront like this. Its shape is like this. Okay. Then direction of ray will be like this. These are the direction of rays. So wave is moving. The direction of propagation of wave is in this direction. Okay. Wavefront is perpendicular to that. Means perpendicular means this is the wavefront. Clear? This is the direction of ray. Then this is perpendicular to the wavefront. This is plane wavefront, and this is the direction of propagation of light in this direction. It is given by the ray. Okay, understood? Now we need to find the angle made by the direction of wave propagation with x-axis. It is not with a wavefront. With wavefront, it is 90 degree. Okay. But with x-axis, what is the angle which we have to find? Now look at this. If you draw a ray, how do you draw? If this is the wavefront like then this is the ray. Okay, ray like this. Outward. Rays coming like this. Rays are coming like this. And wavefront is like this. There, so direction of propagation is perpendicular to the, but we need to find how much angle made the what x-axis and what y-axis, z-axis. Clear? Understood? Now we need to find this. This is our question. Clear? Now see how we will find. Now I will draw. I know one concept. What is that? I need to find a vector which is perpendicular to the wavefront. Okay. In a plane, what is given? If you look at carefully, what I found, what is the coordinate here? C comma 0 comma 0. And what is the coordinate here? 0 comma C comma 0. So I got one thing like very important. You know A cross B. A cross B is equal to C. C vector. It means C vector is perpendicular to A and C vector is perpendicular to B. This is what we learned. Okay. It means C vector is perpendicular to A, C vector is perpendicular to B. What I will do, I will find two vectors in the plane wavefront itself. How we will find? Just look at this. Just the help of triangle law of vector addition, I will find one vector. Just look at this. This is like this. This is like this. So I got this is the resultant vector like this. What is the equation of this? You can take this R1 vector or you can take A vector. Here, this A vector will be by applying triangle law of vector addition. It will be what? This direction like this. Minus Ci cap like this. Minus C I cap plus C J cap. This should tail to head, then it should be tail to head. Minus A vector comes out to be 0. So A vector will be what? C minus C I cap plus C J cap. The similar way I got in xy plane one vector, this is x plane, xy plane. In the similar way, what I need one more vector in the plane wavefront itself. This is z. What is the coordinate? This coordinate is 0, x0, y0, and z is not 0. Clear? So what I will do? I got one more vector like this. Okay, this is one more vector. This is b vector. Clear? Then how to find b vector? It will be what? Like this. C minus Ci like this. Tail to head. Look at this triangle. Triangle. Okay. Tail to head. Then this vector. Is what it will write? C a vector. Then it should be tail to head like this. So b vector will be what? Minus Ci cap plus C a cap. So these two vectors, one vector is a vector like this, like this. This is our plane wavefront, like this. And these vectors are lying in the plane itself. One vector is this. Okay. one vector is this. If you take a cross of these two vectors, like A cross B, that vector will be perpendicular to these two vectors. So that's what we needed. Yeah. So I will find C vector which is perpendicular to A vector and B vector. C vector will be A cross B. What is A vector? Just look at this. Minus Ci plus Cj. Minus Ci plus Cj. Similarly, B vector will be what? Minus Ci plus Ck. Minus Ci plus Ck. Take the cross, A cross B. You click 5. So A is minus C. Z is 0. Similarly, B vector will be what? Minus C. There is no Z like this. So C vector will be what? Like this. What I will write? C square minus A. Okay. Plus K vector. Okay. Which is like that. I think you know how to solve. That's why I directly solve. See any mistake is there? Check. There's no mistake. Clear? So we got C vector. C square will take common. I vector minus, I vector plus J vector plus K vector. So this is the vector which is perpendicular to our wavefront. This is the wavefront. Clear? Perpendicular to this wavefront, this is actually like this perpendicular wavefront. This is C vector. Now we need to find how much angle is being made by this vector with x and y and z. This is like this. This C vector. Now see, this vector is making alpha angle with x-axis, beta angle with y-axis. This is making some angle with gamma with z-axis. But actually they are finding that they want what is the angle made by this vector with the x-axis. How much angle is being made by this vector with x-axis. So simply, if you ask me like, if you want to imagine, then I can make you imagine like this. Make a cuboidal shape like this. Okay, this is x-axis, this is y-axis, and z-axis. Here, this is our C vector. C vector. Here, how much angle? Alpha. So this will be what? If you draw a perpendicular on x-axis, it will get construction. Okay, this is what? Cx. So cos alpha angle will be what? Cos alpha will be raised by hypotenuse. Hypotenuse is mod of C. Here, what is C vector? C vector is C square. Is it C square or what? C square I plus A plus K. Understood? So mod C will be what? Mod C will be under root C square outside under root 1 square plus 1 square plus 1 square. So it will be C square. So how much angle with the x-axis? Cx will be C square like this. Yes, alpha with cos inverse 1 by, if you want to find beta, so it will be same cos inverse 1 by root 3. If you want with z-axis, same cos inverse 1 by root 3. Here, so symmetric. Okay, it shows that our the wave is going to propagate in that direction which is symmetric with x and y and z axis. Meaning is that clear? So this these calculation, like, I know this is little bit tough, but for finding the better solution, like, have to imagine the concept. Okay? Just understand. I know the concept. The direction of wave of light is perpendicular to wavefront. I know that. It means from plane it is perpendicular, and we know the concept of vector cross product. If I know two vectors in plane, then resultant vector will be perpendicular to those two vectors. Simply I find two vectors here, there, then resultant vector will be perpendicular to these vectors. So our ray will be raised just like a ray vector. The ray direction, which shows the direction of propagation of light. Direction. So I just find the resultant vector here. So final answer will be what? Option. Yeah. I hope this doubt is clear. Thank you so much. Thanks a lot.